Welcome back. In this module, we're going to be discussing about cloud governance. What do we mean by cloud governance? Governance in Azure is one aspect of what we describe as Azure management. Azure management has 6 key areas. Those areas are govern, migrate, secure, protect, monitor, and configure. Management itself, in a general high level, refers to different tasks and processes that we are required to perform in order to maintain our business applications and resources that support those business applications. And within Azure itself, Azure has many services and tools that can easily work together to provide complete Azure management. But let's jump into Azure governance in specific. Azure governance provides different mechanisms and process to help us as an organization or individuals to easily maintain control over our applications and resources within Azure. This means that it involves what we call planning of our initiatives and setting different strategic priorities. Governance within Azure is primarily implemented with 2 key services. The Azure policy, which allows us to easily create, assign, and manage what we call policy definitions so that we can successfully ensure rules for our resources. This feature keeps those resources in full compliance with our organizational corporate standards. We also have the Azure Cost Management as the second key service, which allows us to easily track cloud usage and expenditures for our Azure resources and other cloud providers. Now, in a much more broader perspective, we have 5 key areas within our Azure cloud governance. That involves our Azure Management Group, our Azure policy, which we just described, our Azure blueprints, our Azure resource graph, and finally, Microsoft Cost Management, which we just described a few moments ago. Now let's jump into each individual areas to have a brief and quick overview of what exactly these areas entail. The first area we're going to start with is Azure policy. Now, Azure policy within cloud governance helps us to enforce what we call organizational standards, and it also ensures that we are able to assess compliance at scale. Through this compliance and through the usage of what we call a compliance dashboard, we are provided with aggregated views to evaluate the overall state of our environment, also with the ability to drill deeper per resources. One other key detail with Azure policy is that it helps us to bring our resources to compliance through the utilization of what we call remediation. This remediation seeks to look for existing resources and automatic remediation or manual approach of remediation for new resources. Some key usage or uses of Azure policy include, for example, implementing governance for resource consistency, performing regulatory compliance, performing other actions such as security, cost, as well as management. We thereby have what we call a policy definition for some of these examples that I have just listed. And those examples can be found within our Azure policy in the Azure environment. Now, to give us some key examples of what Azure policies might be able to achieve, in one scenario, Azure policies can ensure that our teams are deploying Azure resources only to some specific allowed regions that we choose them to deploy to. Another case sample is that we can use Azure policy to enforce application of resource tags. Another final example is that we can use Azure policy to require different resources to send diagnostic logs to a log analytics workspace. So with that in mind, let us take a deeper dive into Azure policy. Now, within our Azure policy definitions, we use JSON to create what we call policy definitions. These policy definitions have a couple of elements that it can contain, such as display names, metadata, parameters, effects, mode, description, and logical evaluation. Over here, we see a description that gives us a little bit deeper detail on what this policy is doing. It tells us this policy enables us to restrict the locations our organization can specify when they are deploying resources. What this means is that when this policy is deployed, it will ensure that we control the locations that our teams can deploy resources to. When we talk about parameters within our Azure policies, we are talking about field value functions that enable us to pass parameters for different options we want to allow within our Azure policy. In the case of this example provided over here, we see that the allowed values under the parameters section defines us placing our resources under East US, West US, and West US 2. In this case, this will be the only locations that resources will be allowed to be deployed to. We also have different logic operators for our Azure policy. These logic operators give us the ability to apply logic while creating or provisioning our Azure policies. The supported logic operators we have are not, all of, or any of. The not simply excludes different scenarios or requirements. All of includes all of the conditions that are provided for that policy. Any of seeks to achieve a peak of any of the conditions that are met. When describing scope within Azure policy, we take a look at different scopes that we can target to enforce our Azure policy. For example, we can target to have our Azure policy scoped to a subscription. What this means is that it will be applied to a high level where our subscription is what our policy is looking to enforce. What this means is that when we select only a subscription, we are specifically targeting our Azure policy to be met for any resource or resource group at the subscription level. We can also have a scenario where we select a subscription and then seek to choose a specific resource group that would only be affected by this Azure policy. In the case where we want to implement tags for resources created, we can then target a subscription and then select a resource group within that subscription in which that Azure policy would be focused on. This means that whichever policy is assigned for that subscription and resource group, any resources created within that resource group must meet the requirements of that Azure policy for it to pass what we call compliance. The next area we're going to quickly go over within our cloud governance is Azure Resource Graph. Our Azure Resource Graph is basically defined as an Azure service that is designed to extend Azure resource management by providing very efficient and performant resource exploration with the ability to perform queries at scale across a given set of subscription. This is so that you can effectively also successfully govern your environment. The queries that can be initiated within an Azure Resource Graph performs different abilities, such as being able to query resources with complex filtering, grouping, and sorting of those resources by their resource properties. Another ability is that the Azure Resource Graphs can explore resources iteratively based on different governance requirements. We can also use Azure Resource Graph to assess the effectiveness of applying policies in a very vast and large cloud environment. One of the very key things to observe and understand within Azure Resource Graph is the basic understanding of the query language used to query these Azure resources. This query language is called the Coastal Query Language, or abbreviated as KQL. Over here in our diagram, we can see an example of where we are basically using our Coastal Query Language to query resources within our Azure Resource Graph Explorer to find details on which virtual machines exist within a specific current Azure subscription. Based on the query provided here, we then perform a run query that returns a result set that meets the requirement of the query that is provided. In this case, the query has returned one row of data based on the requirement provided within the Coastal Query Language. Over here, we see more examples of our Coastal Query languages. In the case of this example, we are performing a Coastal Copy query that helps us to locate all the available key vaults within our Azure environment. Not only is it doing that, but its specific target is to get the count of all key vaults that exist within our Azure environment. In the next example that we see over here, our Coastal Copy is performing another query where it is selecting the specific columns that must be returned for a search on all resources that exist within our Azure portal. In this case specifically, it is returning the name, type, and location resources or columns for the data set that is returning back to us based on the query. And it is also ordering those data by their name in an ascending form. In this other example over here, we are performing a search on different virtual machines that exist within our Azure portal. Hence, we have the filtering here that says where the type is equal to virtual machines. We're also returning specific columns over here, such as the name, location, and type. And finally, we are ordering by the name in a descending form. In our example over here, we are using Azure Cloud Shell to basically perform similar types of query for our Azure Resource Graph. Within this specific query on our bash session within our Cloud Shell, we are using the azgraph query command to perform an Azure Resource Graph query, where we are returning specific columns, in this case, the name, location, and type. And we are looking for Azure resources where they are virtual machines. Finally, we are ordering the result by the names in a descending form. In the other example below over here, we are also running a resource graph query within our Cloud Shell bash session, where we are returning resources that contain any word that is called storage. We are also performing a distinct type. What this means is that whenever there are repetitions of the rows of data that are returned, we make those rows distinct in the sense that we make them unique. So in a case where we add a row set of data that was returned and two items add the same name, the distinct type brings it to one data, thereby removing any redundant details that have the same naming convention. Over here, we see some examples of some key KQL query functions. We've seen some of this while looking through the few slides that we went through few seconds or minutes ago. In the case of the count, we are counting exactly the number of requirements that are returned back to us based on the query that was issued and ran. The distinct is what returns redundant or same values returned, breaking them down to just one single value so far they all have the same description. And so we have other examples such as the extend, join, limit, MV expand, and so on and so forth. The other area we're going to be looking at is cost management. Cost management enables us to easily reduce cost through some specific techniques and tools provided within our cost management. Within the Azure portal, we can leverage the use of the cost management or cost management plus billing Azure service. With the use of these services, we can easily implement financial governance within our organization by truly focusing on three key areas, which are cost optimization, visibility, and accountability. The cost management is also available within different services in our Azure portal, such as our resource group and our Azure subscription. The availability of this cost management across these different Azure resources is to ensure that each and every team member or individual within an Azure portal environment has the visibility into the cost that they are responsible for. And so they can then optimize their different Azure workloads to maximize more cost efficiency. Cost management is also available independently, as we mentioned earlier, to streamline the process for managing costs across multiple or different billing accounts, subscriptions, resource groups, as well as management groups. Now, let us describe what type of data is included within our cost management concept. Specifically within the billing experience, we can easily manage all the products, subscriptions, and recurring purchases that we can utilize. We can also review things like our credits and commitments, and we can view and pay our invoices that are generated. These invoices are available online or as PDFs and can include bill charges as well as any applicable taxes. Over here to our right, we see an example within our Azure portal of cost management plus billing Azure service. In this current screenshot, we see the cost analysis under the cost management that gives us a visualization of usage of Azure services and the cost associated with the resources that were created with those Azure resources. In the case of this example over here, we can see the top Azure services and the cost available to them. Over here, we are giving an highlight of the different locations within our Azure portals and the cost associated with those locations. The bar chart area over here spreads the cost within the different Azure services across a timeline of February. Given the X and Y axis over here, when we look at the different days within the month of February, we can associate them with the cost that is given and provided here, which was incurred across these different days. And so, with all these details provided, let us jump into the practical session to have a good feel of how we can implement each one of these key areas of our Azure cloud governance.